Integral of x sine x over 2 dx. And as you can tell, we have to use integration by parts. It'll be, yeah, that's like what this problem is best suited for, because we have a product, a product of two x functions in our integrand. So always choose your u to be something you can easily differentiate and your v to be something you can easily integrate. That's the whole point of integration by parts. It makes the problem a lot easier. I'm going to choose my u to be x and my dv. Always choose your dv rather, not your v, but your dv to be something you can easily integrate. So I'll make this my dv. So if u equals x, let's have a little table here, and dv equals the sine of x over 2 dx. What's du going to be? Du is simply dx, because that's a 1 in front of the x. And our v is going to be the integral of this. What's the integral of sine? It's negative cosine. But keep in mind, it's not simply the sine of x, it's the sine of x over 2. How do we take the integral of that? Well, integral is the opposite of differentiating. Instead of multiplying by the derivative of x over 2, we're going to divide by it. So it's going to be negative cosine of x over 2 divided by the derivative of that, which is a half. When you divide by a half, you are multiplying by 2. So we're going to double this. So it's going to be negative 2 cosine of x over 2. Let's now plug what we have here into that formula. So the integral of u dv is going to be our u, which is x, times v, which we've identified to be that. So x times negative 2 cosine of x over 2 minus the integral of v, which is this again, negative 2 cosine x over 2 du, and du is simply dx. Okay, let's simplify. This is simply negative 2x cosine x over 2. 2 minuses make a plus. 2 plus the integral of 2 cosine x halves dx. Okay, we have a constant here. You can always pull out a constant whenever you're integrating or differentiating. So let's go ahead and do that. I'm simply rewriting with the 2 pulled out. Okay, so now we simply have another integral. This is more manageable than the first one we started with. That's one of the key signs you're on the right track. If you have a more complex integral in the second round, then you did something wrong. You probably chose your u's and dv's incorrectly, and you should go back and re-choose them. So now, how do we integrate this? Well, the integral of cosine is sine. But we just have to keep this in mind. Just like we had here, we had the 2 because of this half. We're simply going to have the same thing over again. So, negative 2x cosine x over 2 plus 2 times integral of cosine is sine, cosine of x over 2. Now, keep in mind, we have this half here, so we're going to divide this whole thing here by the derivative of this. What's the derivative of 1/2 x? It's 1/2. So this whole thing divided by 1/2 plus c. When you're divided by a half, it's the same as multiplying. We usually don't write complex fractions like this. So it's much better to just multiply the whole thing by a half, by 2. So instead of having another 2 times 2 here, I'm just going to get rid of this 2 and make that a 4. Make that a 4. And there should be a cosine here, sorry. So instead of having this, usually having a leading negative is just, it looks awkward, so I'm just going to factor out a 2. I'm going to start with positive, so I have a 2 sine x over 2 here minus x cosine x over 2 plus c. And this is our final answer. Thank you very much.